Hello, welcome. It's Thevenin. Today we are going to learn about what is Thevenin's theorem and how to set up Thevenin equivalent circuit. So basically, Thevenin's theorem is a simplification method to convert a complex circuit into a more simplified form. This simplified version of the circuit will have a single voltage source, an equivalent resistor, and a single load resistor. And the circuit would look something like this. Thevenin's theorem is useful for analyzing networks with sources that are not in series or parallel, or reducing as many components as possible in our circuit to make our calculations easier. Thevenin's theorem is also used to help us analyze and study the behavior of complex circuit when the value of a particular component is constantly changed. So we don't have to calculate all the way through for our desired values. Here are some of the examples of complex circuits. They look approachable through textbook, but practically when setting up on breadboards, the wires will get messy. So anyways, for today's video, we will go through the last circuit and the second circuit. Alright then, let's proceed to our circuit problem 1. Let's suppose your teacher or professor tells you to conduct an experiment based on the maximum power transfer theorem using this resistor, where you have to constantly change the value of resistance and find its corresponding power value. To make your calculations easier, you can convert this messy portion of the circuit into a simple series circuit using Thevenin's theorem. Right then, to use our Thevenin's theorem, we need to follow some steps. So step 1, remove the load resistor. So we keep an open connection between A and B. So the circuit would look something like this. So there is an open connection between A and B. Step 2, find Thevenin resistance. For step 2, to find Thevenin resistance, first we need to remove all power sources. If it's the voltage source, we short circuit it. If it's a current source, we open circuit it. Since this is a voltage source, we will short circuit it, and the circuit would look something like this. Practically, to measure the resistance, we will connect an ohm meter. But theoretically, we need to calculate our total equivalent resistance, and total equivalent resistance. From the diagram, we can see that the current from the ohm meter is traveling through the wire and is getting divided between the two resistors. So we can say that R1 and R2 are in parallel. So to find the equivalent resistance, we need to add them up. So the formula for the trick to add parallel resistors are 1 by RT, so 1 by R1 plus 1 by R2. Therefore 1 by RT is equals to 1 by 3 plus 1 by 6. So using calculator, so the value will be 2 ohms. So we got our Thevenin resistance. Let me specify that. So we got our Thevenin resistance value. Now step 3 will be finding the Thevenin's voltage. To find Thevenin's voltage, step 3, to find Thevenin's voltage, we need to restore our power source. We are going to restore our power source, and we will connect our voltmeter across A and B. But theoretically, to find the voltage across A and B, we can do one thing. The voltage across A and B is the same as the voltage drop in R2. Therefore, finding the voltage across R2 will be the same as the voltage across A and B. Therefore we connect our voltmeter across this. So basically it's a simple series circuit, and we can use either KVL or KCL, but we don't know the voltage across R1. So we are going to use VDR. What is VDR? VDR is voltage dividing rule. Voltage dividing rule tells us how much voltage drop is across a resistor in a series circuit, in a series network. So VDR, we are going to use VDR. So voltage, so basically the voltage across resistor 6 is voltage across resistor 6 is equals to resistance of R2 divided by the total resistance, which is 3 plus 6 multiplied by the total voltage. And what is the total voltage? The total voltage is 9 volts. 9 and cancel, and therefore the value is 6 volts. The Thevenin's voltage value is 6 volts. Now we can redraw our circuit diagram. Our circuit diagram will look like this. Now let me draw the resistance. Oh, that wasn't too bad. Okay. How much was the value? So it's RN. What's the load? What is the Thevenin's resistance? 2 ohm. And what is the Thevenin's voltage? 6 volts. Plus minus. There you go. This is our simplified circuit. It's easy. Thevenin's theorem is easy. It makes our calculations easier. It makes our experiment easier. And there you go. Alright then, let's head on to our second problem. We are going to use the same rule for this circuit as well. Same Thevenin's theorem rule. Rule number 1, remove the load resistor. So we are going to redraw the circuit again. A, B, 4. There you go. Now step 2. We are going to find the Thevenin resistance. We are going to use the same rule as before. To find the Thevenin resistance, we need to remove our power source. Because this is a voltage source, we are going to short circuit it. And we have to redraw the circuit diagram again. So, now to find the Thevenin resistance, we have, which is also called equivalent resistance, we need to find the total sum, and we need to know which resistors are parallel to each other or series to each other. So I can say from here is that it's 0 ohm at this wire, in this wire. So 2 and 0 are in parallel, so which gives us 0 ohms in total. 0 ohms in total, and the 4 ohm will replace the 0 ohm and it will become 4 ohm. Therefore 4 ohm and 6 ohm will be parallel to each other. And I have to redraw the diagram again. And now let's calculate the Thevenin resistance. To find Thevenin resistance, we find the sum of 6 and 4 in parallel. So basically we do the same thing again. 1 by RT is equals to 1 by 6 plus 1 by 4. This will give us, it's 2.4. It's 2.4 ohm. So we found our Thevenin resistance. Now step 3. We need to find our Thevenin voltage. To find Thevenin voltage, we need to restore our power source. And we need to redraw our diagram again. But wait. We have the power source here. To find the voltage across A and B, the voltage across A and B will be the same as the voltage drop in R1. The voltage drop across R1. So we are going to find the voltage across R1. So basically 4 and 6 will be in series while 2 will be in parallel to them. And then we will redraw this diagram again. 4 and 6 are in series, so we are going to use VDR to find the voltage across the resistor 6 or the voltage across resistor R1, and the formula would be VT is equals to the resistance of R1, which is 6, divided by the total resistance in series, which is 4 plus 6, not 4 plus 6 plus 2, only in series, not the parallel, only in series. So it's 6 plus 4, the whole multiplied by the total voltage. What is the total voltage? The total voltage is 8. It's 648, which gives us divided by 10, which gives us 4.8. The voltage, so we got our Thevenin voltage, which is 4.8 volts. 4.8 volts. There you go. So we redraw our diagram. Step 4, yeah. Step 4, we redraw our diagram. And we replace our load resistor. The value of voltage is 4.8 volts, it is the Thevenin's voltage, and the resistance is 2.4 ohm, while we have the other, right? Yeah. And the load resistor will be 2 ohms. So we are going to investigate on this component, on this resistor. This will make our calculations much more easier. See, this is just a simple series calculations. But Thevenin's theorem has some limitations. It will only work for circuits that has linear components, and it will only work for experiments that are being investigated on a single resistor only. And if you're wondering what are linear components are basically resistors, capacitors, and inductors, while non-linear conductors are semiconductors, diodes, and transistors. So be careful of that. Let me give you an overall summary of today's lesson. Use Thevenin's theorem to make your complex circuit into a more simplified form. To use Thevenin's theorem, first remove the load resistor. Second, find Thevenin's resistance by removing the power source and finding the equivalent resistance of the circuit. Then third, find a Thevenin's voltage by restoring the power source and using either KVL or VDR. Number 4, redraw the circuit or reconstruct the circuit with the Thevenin values you got. Alright, then that's it for today's video. If you like my content, please press the like button and subscribe for more lessons.